The following is an example of extended exponential growth and decay. A cup of coffee, initially at 95 degrees Celsius, is cooling according to the exponential function P equals N plus A multiplied by e to the power of kt, where P is the temperature of the coffee in degrees Celsius and T is the time in minutes. The ambient temperature of the room is 21 degrees Celsius. After 5 minutes, the temperature of the coffee is 80 degrees Celsius. At what time will the temperature of the coffee reach 40 degrees Celsius? Now, the first thing to think about is what happens as T approaches infinity. So this is a cup of coffee that's cooling, starting off at 95 degrees and approaching 21 degrees Celsius. So as T approaches infinity, P will approach 21 degrees. So this AE to the KT will disappear and P will approach N. So therefore, N equals 21. Now let's think about what happens at time t equals 0, so the instant the coffee is poured. P is the sum of N and A. So 95 equals 21 plus A, since we've already found N. So therefore A must equal 74. So recall that the sum of N and A is the initial value of P. So the value of P when time equals 0. Hence we could write the formula as P equals 21 plus 74 multiplied by e to the power of kt. So that's usually the first step with these type of problems. We try and find the N and the A first. Next, we need to find the K, the growth constant. And for that, we'll need some extra information. Now we know that the temperature is 80 degrees Celsius when time equals 5 minutes. So after 5 minutes since the coffee was poured. So substituting P equals 80 and T equals 5 into this formula here, we can solve for K. So 80 equals 21 plus 74 multiplied by e to the power of 5k. And we'll solve for K, so subtracting 21 from both sides, we have 59 equals 74 multiplied by e to the power of 5k. Dividing both sides by 74, we have 59 over 74 equals e to the power of 5k. So we take the natural logarithm of both sides. So we have ln of 59 over 74 equals 5k. Finally, dividing both sides by 5, we have k equals 1 on 5 multiplied by ln, or the ln of 59 over 74. Now I'm going to keep this in exact form. So now that we've found the growth constant, next we need to find T, or we need to find the time T when the temperature equals 40 degrees. So we'll substitute P equals 40 into the formula now that we have our value of K, and we're going to solve for T. So 40 equals 21 plus 74 multiplied by e to the power of kt. We'll rearrange this formula, of course, and make T the subject of the formula. So subtracting 21 from both sides, we have 19 equals 74 multiplied by e to the power of kt. Dividing both sides by 74, we have 19 over 74 equals e to the power of kt. Now remember, we know the value of k already. It's here, we've already determined that. Next, we take the natural logarithm of both sides, or ln of both sides. So ln and e, of course, cancel. So we end up with ln of 19 over 74 equals kt. And of course, dividing both sides by k, we have t equals the ln of 19 over 74 divided by k. And evaluating that, we get t equals 30.0101581 minutes, or around the 30-minute mark is when the temperature of the coffee will reach 40 degrees Celsius.